Volcanoes are major natural hazards and they can affect air traffic, agriculture and even the climate. So our research tries to better understand how volcanoes work and what processes lead them to erupt. What we found is by studying the most active, largest volcano in Europe, Mount Etna, located on the island of Sicily in Italy, is that arrival of new magma at depth, at around 10 kilometers beneath the surface, can trigger an eruption in 2 weeks' time. So how do we get this information from what's happening inside the volcano? We're fortunate to have volcanic rocks from past eruptions, which represent magma that has cooled down in contact with the atmosphere. And these volcanic rocks contain crystals that formed at depth and record what happened just before the eruption. So the challenge is to get this information from the crystals. And so our approach is to use new laser technology to create chemical maps where we can read what happened before the eruption. So in geology, the past is the key to the future. So having this information from the tiny crystals on past eruptions, we can better understand how volcanoes work and interpret future signs of unrest. So for example, as the magma comes up to the surface, it pushes rocks apart and it builds up pressure inside the volcano. And this may translate in earthquakes that we can measure from the surface, and also in the formation, inflation of the volcano that we can measure with GPS. We can also see if the volcano is degassing and what kind of gas, what chemical composition that gas has. So from this real-time information, plus the information that we get from the tiny crystals on past activity and past behavior, we can better or more accurately interpret what is likely to happen and then make decisions on travel or potentially evacuation of population.